let's do an example. Suppose we have the series n squared over 3 to the n plus 4, n going from 0 to infinity. All right, so the ratio test tells us we want to take the limit as n goes to infinity of a sub n plus 1 over a sub n. Absolute values. In this case, we don't really need the absolute values because these terms are all positive anyway. But let's look at what this is. A sub n is just n squared over 3 to the n plus 4. A sub n plus 1, I'm going to write above it here, is n plus 1 squared over 3 to the n plus 4. Or 3 to the n plus 1 plus 4. All right, so the limit we're going to do is this. Limit as n goes to infinity of n plus 1 squared over 3 to the n plus 1 plus 4. And then we're supposed to do that over the other thing. N squared over 3 to the n plus 4. Now, that gets ugly quickly, so instead of writing it out like this, I'm going to go ahead and just invert and multiply. So instead of dividing by a sub n, I'm going to multiply by the reciprocal of a sub n. And now I've got to do this limit. It looks daunting, but it's not really that bad because we can rearrange the stuff. I'm going to put the 3 to the n plus 4 here. And I'm going to put the 3 to the n plus 1 plus 4 underneath it. And then I'm going to put the n plus 1 squared over n squared together. And now I can break this into two limits. Three to the n plus 4 over 3 to the n plus 1 plus 4 times this. All right. Now, this n plus 1 squared, I'm going to FOIL that out. You get n squared plus n, well, 2n plus 1. And now let's look at dominant terms here. For this limit, the dominant term on top is n squared, and the dominant one down here is n squared. For this limit, the dominant term is 3 to the n. Down here it's 3 to the n plus 1. So overall, this limit over here is just 1. So I get the limit as n goes to infinity of 3 to the n over 3 to the n plus 1 times 1. Well, okay, 3 to the n plus 1, I could break that up if I wanted to into 3 to the n times 3, cancel. What I'm left with here is 1/3. Got 1/3 times 1, or just 1/3. That is less than 1. Therefore, by the ratio test, this series is absolutely convergent.